Yes, good morning all. Just give me a minute. Just give me a minute. Okay. Yes, good morning. Let me start today's class with the second problem. As all of you aware, we were discussing the unit 5, under which in the previous classes I clearly explained you about the only theory topic, that is compensation. In a single line I can say compensation means the repair. And now after that I have given you briefly and a clear demonstration of what is state variable concept. And now in the previous class I went for one problem, that is how to obtain the state model. What is state model means? Representing the equation in this, representing the given system in the state variables in this format: x dot is equal to ax plus bu, where u is the input and x is the state variable. What is state variable means? Clearly I explain you all of you that the variables which are varies with respect to time in the given system can be considered as a state variable. That's it. Now how, why I am taking this one as x dot means, as they are varying with respect to time, hence we are going to write the expression in terms of what, dx by dt. So this x will be any of the variables. If we are working with electrical circuits, then it will become either it will be voltage or current. Okay, how to obtain that one? We have solved one problem here in the previous class. So this problem I solved in the previous class. This one, a simple RLC circuit, R, L and C circuit. For this RLC circuit, if you observe this RLC circuit, it is having different variables V in and then V naught, along which the state variables he assumed in the given problem as V I and V naught. Hence, according to the procedure, I followed some steps, two steps of procedure. First step is you have to write the, you need to assume the state variables. Second step is you need to write the differential equations, and third step is you need to represent those differential equations in terms of variables x1, x2, x3 in terms of matrix form. So in these three steps of procedure, we can able to solve the same thing. Now let me continue this class by solving the second problem also. So here in the, if you observe this second problem, he has asked you, he has given an electrical circuit, this one, and he has asked you to to represent the state model by assuming the state variables are V1, V2, and the current flowing I. So if you observe here, V1 is the this nodal voltage in the given in the circuit, and V2 is the this nodal voltage, and I is the current flowing through inductor. So as part of that one, as he has given V1, V2, and I are the state variables. Hence, as a first step, you just I am assuming x1 as v1, x2 as v2, and x3 as a I in the order what he has given in the problem. So if x1 is v1, then what about x1 dot? X1 dot will be v1 by dt, and x2 dot will be dv2 by dt, and x3 dot is equal to di by dt. Now the last step is you need to write the expressions for x1 dot, x2 dot, and x3 dot. What is x1 dot? Once again, x1 dot is dv1 by dt. So dv1 by dt equations రాయాలంటే how you can write? I mean here there are options. dv by dt రాయాలంటే you need to go for writing the expression for current I. So you can write I is equal to c into dv by dt, as we are having formula from basic formula. So to get dv by dt, I need to write a current expression for uh, current expression for the current flowing through the capacitor. Now, if you observe here, the current let this is the current across this particular one. If you are able to how to write the find out the current flowing through capacitance C1, means as capacitor C1 is another end is connected with R1, and also another end is connected to L. So let me go with this particular one. If you apply KVL at this particular node V1, if you apply KVL at this particular node V1, then you will get what for the given circuit. So if you observe your circuit looks like this. So this is V R, this is your C, and this is your L. So L, this is V1, and now here this correct another end is connected to Vin. Hence, how you can write the expression for at the, if you apply KVL for this particular node. So I can write here as V1 minus Vin by R1, that is V by R, and then C1 into dV by dt plus I is equal to 0. So from this expression, I can write directly dV1 by dt is equal to V1 minus Vn by C1 R minus I by C. Okay. Now in the same way, next applying KCL at node 2. At node 2, if you observe in the given problem, here at this particular node 2, he has given, let this is your node 2 V2. So at this particular node 2, capacitor C2 is connected here. Okay, for the given problem, and then capacitor resistance, you just refer the node sum what I already given, the same problems I am solving here, and common element is I, but in this direction what we have considered already, the direction of current I is in this way. So hence you can write the expression for this one is, so if you apply KCL for this particular rule, for capacitor it will be equal to C into dV by dt. For I, as it is the direction of current is incoming, hence minus I, plus the voltage here is here resistance is R, so hence current is equal to V2 by R2. Now write the expression in terms of dV2 by dt, you will get the second expression. And similarly, now finally the third variable is you need to get the expression for di by dt. All of you are aware that the voltage across the inductor V is equal to L into di by dt. So here is the voltage across the inductor in the given problem is the common voltage. So inductor is connected between V1 and V2, and the current flowing here is like this. So you can write the expression for this one as what as already written, that I can write here as V1 minus V2 is the voltage across inductor is equal to L into di by dt. L into di by dt. Now if you rearrange the terms, then you will get V1 minus V2 by L. This is your equation 3. So equation 3, 2, and then 1. So by using these three equations, just as already I assume that x1 is equal to V1, x2 is equal to V2, and x3 is equal to I. So replacing those terms, then you will get equation 4, 5, and 6. Representing this equation 4, 5, and 6 in matrix form will give you the state model. Here is the end of problem. So this is equal to x dot is equal to ax plus ax plus b, ax plus bu. Like this, you need to solve the problem. Furthermore, I am having one more problem here. The third problem. So just I am giving you the 5 minutes of time. Please try to solve yourself. Now here he has given the resistance. He has given the resistance R1, L1, R1, L1, R2, L2, R1, L1, R2, and then L2. Let me solve the third problem myself here in this particular uh, class. So let me solve myself this problem. So he has given, let me write here clearly. See L1, L2, R1, R2, I1, I2, voltage across capacitance is VC, VC. Now in this problem, he has asked you to find out the state model, and he has given the state variables are I1, I2, and VC are the three state variables. So solution for this particular problem is as usual. Just listen carefully. Your first step is assume the given state variables are x1, x2, x3 like this. And remember all of you, here we are not testing your mathematics. Hence, in the examination point of view, maximum three variables he will be asked you to assume. So if he is asking you to assume more number of variables, then more number of equations you are going to get. So more equations means 4 by 4 matrix, 5 by 5 matrix ఇట్లా వచ్చే chances ఉంది. Hence, we are not testing your mathematics. We are testing whether you can able to convert the given given circuit to state model or not. State model means that is x dot is equal to ax plus bu. ఈ ఫామ్ లో మీరు తెస్తారా లేదా అనేది we will test you. That's it. Okay. Now here, so first step is x1 is equal to I1, which implies x1 dot is equal to d I1 by dt. In the same way, x2 is equal to I2, which implies x2 dot is equal to d I2 by dt. And also he has assumed, sorry, here this is only x2. and this is x2 dot. So x3 is equal to vc, which implies x3 dot is equal to dvc by dt, dvc by dt. Okay. Now here the first equation is what I can write here, the first. So hence you need to write the three equations. You need to write the three equations as he has asked you to uh, assume three are the state variables, and now observe the question itself. In the question itself, the number of state variables ఉండొచ్చు. అంటే జనరల్గా చెప్తున్నాను వితౌట్ రైటింగ్ హియర్. ద నెంబర్ ఆఫ్ స్టేట్ వేరియబుల్స్ ఉండొచ్చు. ఏమి వి ఇన్ వోల్టేజ్ అక్రాస్ R1, voltage current flowing through R1, voltage across L1, current flowing through L1, like this. అందులో మీకు ఇచ్చిన క్వశ్చన్లో I1, I2 and VC. సో I1 means you if you to get this di1 by dt, all of you aware that ఎప్పుడైనా గుర్తుపెట్టుకోండి, కరెంట్ di by dt రావాలని you need to use this expression, voltage across inductor is equal to dl by l into di by dt. అండ్ వోల్టేజ్కి రావాలంటే you need to write the expression for current, I is equal to C into dV by dt. These are the only two options only. Now voltage ki rayalante I need to go for applying what? KVL. So to get dl I by dt, L into di1 by dt, to get that expression I am writing the KVL for loop 1. Then you will get V in is equal to R1 I1 plus L1 di1 by dt plus directly Vc. So from this expression I can write the expression as di1 by dt is equal to di1 by dt is equal to, I can write V in divided by L minus R1 by L into I1 minus 1 by L into Vc. 1 by L into Vc. Next is to get L2 into di2 by dt, I will write the expression as 0 is equal to, applying KVL for second loop, L2 into, you will get here in this particular expression itself di2 by dt plus R2 I2 plus Vc, which implies directly we can write di2 by dt is equal to minus R2 L2 into I2 minus 1 by L2 into Vc. What about the last expression? So you need to get dV by dt. So to get dV by dt, you need to write the expression for current flowing through capacitor. So what is the current flowing through capacitor? If you observe here, what is the current flowing through capacitor? It is the current flowing through capacitor is, you can write the difference of I1 minus I2. I1 minus I2 is equal to C into dVc by dt, which implies you can what about the third variable, you can write dVc by dt. dVc by dt is equal to what you can write here, Amma? What you can write here, 1 by C into I1 minus 1 by C into I2. So this is your equation 3, equation 2, and then this is your equation 1. Now next, last step is, before represent these equation in matrix form in terms of state variables x1, x2 and then x3. Now if you represent these equation in terms of state variables, then you will get the first equation will implies So the equation 1 will you will get here as equation 1 is equal to, so x1 dot is equal to minus r1 by l1 into x1 minus 1 by l1 into x3 plus 1 by l into input and u, equation 4. In the same way, equation 2 implies x2 dot is equal to minus r2 by l2 into x2 minus 1 by l2 into x3. This is equation 5. Now in the same way, what about the third equation? Your third equation implies x3 dot will be equal to 1 by c1, sorry, directly c ammadi, 1 by c into x1 minus 1 by c into x2, equation 6. So last step is representing these equation in matrix form. Will gives you the state model. So finally, if you represent those equation in matrix form, you will get here as x1 dot, x2 dot. So 3 equation means you will get 3 by 3, and maximum I told you from the data of previous question papers, you are going to get only 3 by 3 maximum matrix. So converting those equation in matrix form, you will get the answer as, so x1 dot is equal to minus r1 by l 0 minus 1 by l1 1 by l1, and x2 dot is equal to 0 minus r2 by l2 minus 1 by l2, and this is what 0, 1 by c minus 1 by c 0, and this is also 0. Hence what I can write, x dot is equal to a x plus du is the representation for your given such system, where a is equal to this matrix and b is equal to this matrix. Here is the end of the third problem. Here is the end of this third problem. Okay, just take the screenshot or whatever. Already I have given the notes, hence no need to worry. Now next I am going for next problem here. So overall conclusion of this problem is he will be giving you the electrical circuit, and also he will be giving you the state variables. These are the state variables, and in the question itself he will be giving you. Even though if he is not giving, you just consider the current flowing through inductor as a state variable and the voltage across capacitor as a state variable. I mean these two are the variables which in the given circuit which are variable parameter with respect to time. You can't consider the voltage or current flowing through resistance are the state variables. I means According to Ohm's law, the voltage or current flowing through a resistance is having constant value. There is the current or voltage may not be dynamic with respect to the resistance R. Okay, with respect to the resistance R. Hence, in general, for inductor, the dynamic variable will be current, and for old capacitor, the dynamic variable will be voltage. Even though if he has not given the data, then of course guarantee istadu. ఒకవేళ ఇవ్వకున్నా you can assume those things as a state variable. Okay, point to be compulsory noted that state variable అంటే dynamic variables కి మాత్రమే మనం expressions రాస్తాం. In the given circuit there are three dynamic variables. ఆ త్రీ కి మనము x1 x2 x3 అనేది అజంప్షన్ చేసుకొని di by dt or dv by dt అంటే ఫస్ట్ ఆర్డర్ డిఫరెన్షియేషన్ ఏ ఈక్వేషన్ రాస్తే మనకు వస్తుందో that we have used. And simple logic without any confusion, if you need di by dt, then you need to 100% you need to write the expression for voltage kabatti apply kvl. Okay, for getting the expression for current, dynamic current, you write apply kvl, and for getting the expression for dynamic voltage you need to go for what? kvl. You need to go for kvl. That is current expression rayala. Current expression, after you will get the three equations. You just rearrange those three equations in terms of your given asked state variables, and then finally replace those state variables with x1 x2 and then assume x1 x2 and then x3 state concepts, and finally the last step is represent those three equations in matrix form. So this is known as what? Your state model. So this is known as what? Your state model. Okay, so here is the end of this problem. Next I will directly jump to the next problem. So if you observe that next fourth problem directly I have given here. So here in this the fourth problem he has here once again I will write this circuit here. So here the fourth problem. So he has given you an inductive circuit like this. He has given you an inductive circuit like this. So L1 he has given and L2 he has given with capacitor connected and resistance R2. So he has asked you to find out what the state variables are Vc and then I1 and then I2. So assume Vc is equal to x1, x2 and then x3. Then you need to get dVc by dt. How to get dVc by dt? One simple expression. The current flowing through these two. Observe the current here is the current flowing through these two. If you observe the given circuit, in the given circuit, the current, both are current entering into the capacitor is same direction. Hence, I1 plus I2 is equal to C into dV by dt. So with this one, dC by dt, you will get the first equation. Now in the same way, Vin is equal to, what you can write here, Vn is equal to, up to get L into di by dt directly you can write as applying KVL, then I1 into R1 plus L into di by dt plus Vc. So just rearrange the terms, you will get equation 2. And the same way for getting L2 ante em cheppinanu, L means current, di by dt means once again voltage expression means applying KVL for second loop. Then as there is no voltage source, left hand side is 0. So Vc plus L di by dt plus I2 R2 you will get. Now you write the expression, then you will get the third expression as this one. Now replace those three terms, so you will get x1, x2, x1 dot, x2 dot and x3 dot expression and convert into matrix form. You will get the same thing. Verify with your, do it personally and verify your answer. What I have supplied, the same thing. So here is the end of the first concept, that is the representation of state model for the given electrical circuit. If you are having any doubts, I am giving you 1 minute of time. Feel free here to ask. So overall conclusion of these things is, and remember all of you, I told you already that maximum number of state variables he will be asking you, there is only 3. Why means more number of variables, more equations, and more order of the obtained state model matrix. Obtained state model. So maximum 3 state variables are routed on. So this is the overall conclusion of this, and you will be asked you to find out the question will be, you will be asked you to find out the state model, not find out, to represent the state model for the given electrical system. ఎలక్ట్రికల్ సిస్టమ్ మాత్రమే ఉందమ్మా మీ సిలబస్లో. ఎలక్ట్రికల్ సిస్టమ్ ఇచ్చి మీకు మ్యాట్రిక్స్ రాయమంటారు. హౌ టు రైట్ దట్ వన్ మీన్స్ ఫస్ట్ డైనమిక్ వేరియబుల్ అజంప్షన్ చేసుకుంటాం. క్వశ్చన్లో గ్యారంటీ ఇస్తాడు. అజంప్షన్ చేసుకొని యూ అజ్యూమ్ దోస్ వేరియబుల్స్ ఇన్ టర్మ్స్ ఆఫ్ ద orders x1, x2 and x3 in this order, x1, x2 in the based upon that one. Write the 3 equations and convert those 3 equations into these variables, and then finally write the matrix. Okay, now here is the end of this first topic. Now next is once again the same represent getting the matrix, but from the transfer function, not from the electrical circuit, but from the transfer function. So in a transfer function, if he has given you the transfer function, okay, if he has given you the transfer function like this, then how to represent those that transfer function means in state model means very simple concept. So you just here he transfer function is ratio of output by input, ratio of output by input. So you just rearrange the terms, in terms of highest power of s power 4, in terms of highest power of s power 4, first step. And second step is let the output, the one first term, no differentiation variable as x1, then one differentiation s into y means first order differentiation, which is also equal to x1 dot. Let that is equal to x1 dot, or which is also equal to x2. And similarly s square into x2 dot is equal to x3, and similarly s power 3 into x3 dot is equal to x4, and similarly s power 4 is equal to x4 dot, which is also equal to x5, but instead of writing the expression for x5, by using this the given equation, you just rearrange the terms in terms of x4 dot, in terms of what, x4 dot, in terms of x4 dot. Then write the expression means x4 dot you are going to get from the given question. And already you assume that x1 dot is equal to x2, okay, x2 dot is equal to x3, and x3 dot is equal to x4. So if you write the expression for this one, you will get 1 like this for x1 dot, x2 dot, and x3 dot. And for x4 dot from the given problem, you just form this row. This will gives you what, the state model for the given transfer function. Transfer function actually find out, it is very easy to find out the things here. Now next, second problem on this transfer function. He has given you the 50 by s square plus 16s plus 64, he has given like this. So y of s by u of s is equal to 50 divided by s square plus 16s plus 64. ఇలా ఇచ్చినాడు. దీనికి రీఅరేంజ్ చేస్తే you will get highest power is s square into y of s is equal to this one. So let I am assuming x1 dot is equal to x2 and x2 dot is equal to x3. But actually x2 dot is equal to s square into y of s. If you send all this term to the right side, then you will get x2 dot is equal to, you will get this expression. So then x1 dot is equal to what I already assume as x2, that is 0 and 1. And then from the given problem, you are writing the expression for, after writing the expression for x2 dot, converting into matrix form, you will get this row. For x2. So in this way you can represent the given transfer function into state model without any procedure. ఒకటే ఈక్వేషన్ వస్తుంది. ఆ ఒకటే ఈక్వేషన్ నుంచి you need to find out the same thing. Now coming to another model of problem. So another model of problem, you refer your notes. In the previous two problems, in the numerator it is a scalar quantity. So if you cross multiply these two things, you will get 50 into u of s. Once again, a scalar quantity. But now if you are having s square term here in this particular problem, once again I am writing here s square plus 2s plus 4 divided by s power 3 plus 3s square plus 6s plus 10. 6s plus 10. So if you observe this one here in the both in the numerator and denominator there are s terms. So if, as there are both the numerator and denominator there are s terms. S terms unnappudu if you cross multiply, then you will get u will be multiplied by s square. U input will be multiplied by s square plus 2 into s. 2 into s like this, 2 into s. So if it is multiplied by s square means it means that it can also be written as d square u second order differentiation dt square. So s square will be for second order differentiation. So it means that you are going to get the input as in terms of differentiation. But actual our state model is, if you observe your state model representation, your state model representation is u is the only scalar quantity, not the dot, not the dot. Scalar quantity means there is no differentiation. So hence, if input is a scalar quantity. So if here if the problem in the given transfer function in numerator also if he has given yes, then you will stuck up. You can't get in this format. You can't get the problem into x dot is equal to ax plus bu. ax plus bu ఈ format లో రాదు. ఎందుకంటే bu is a singular quantity. Now here you will get, if you cross multiply, you will get u multiplied by some s term. S term means differentiation. And in these cases, what you need to do here is you need to split those numerator and denominator two parts. One you need to assume as some another you need to multiply the left hand side as actually he has given y by u. So y by u also equal to y by x and some x by u. So you split one part y by x into numerator like this, and you split one part into the denominator like this. So now separately, now once again you follow the same procedure. Separately write the expressions for the first term, that is m y of s by x of s. For that particular one, if you write, then you will get this equation 2. So in the same way, and for the numerator part, if you write, then you will get this equation 1. So equation 1 means s power 3 into x of s plus this one. All the terms you will get in terms of this one. So let assume x1 dot is equal to x2, x2 dot is equal to x3, and then x3 dot is equal to actually x4. But from this expression, write the expression for x3 dot. x3 dot give me raste, you will get this expression. Now writing the expression for that part, now you will get x dot is equal to ax plus bu in this for first term. For the first term. Now in the same way for y of s by x of s, you do the same procedure what we have done. Then you will get the expression as you will get some matrix. So you represent that matrix in terms of y. So this y matrix is known as what? The y matrix is known as what? Output matrix. Y is equal to cx plus du. cx plus du. So overall state model is, I can write x dot is equal to ax plus bu, representing in terms of state variables, and additional y means output. Y is equal to cx plus du, representing the output in terms of this one. So here ఏం చేయట్లేదమ్మా, ఇట్లా న్యూమరేటర్ లో కూడా ఇలా ఉన్నప్పుడు యూ జస్ట్ స్ప్లిట్ ఇన్పుట్ అండ్ అవుట్పుట్ సపరేట్లీ. సో ఇన్పుట్ అండ్ అవుట్పుట్ ఇట్లా సపరేట్ గా స్ప్లిట్ చేసి ఇన్పుట్ కి సపరేట్ గా రాస్తాం. దిస్ విల్ గివ్స్ యూ స్టేట్ మోడల్ x dot is equal to directly ax plus bu. Okay, ax plus bu, and output ki separate రాసినప్పుడు you will get the output expression, output matrix in this. So ఈ రకంగా we will try to solve the problems for what? We will try to solve the problems for if he has given the matrix. Okay, if he has given the matrix. Now next model of problems is next model of ఇంతవరకు అయిపోయిందమ్మా. Let me conclude first. So first two ways lo you can able to get the matrix. That is, one is x dot is equal to ax plus bu is the state model. X dot is equal to ax plus bu in terms of state variable, and output ki kuda kavalante the expression is y is equal to some cx plus du. So this is the complete state model. So this can be represented by using if he has given circuit, then write the equations and convert into matrix. And now if he has given transfer function, then rearrange the terms y by u cross multiply చేసి convert into equations, and then once again write into form of matrix. Okay. Now if he has given both numerator and denominator s terms, then you separate your y by x output with respect to state, and also out in output and input separate ga consider cheskoni you write the expression for separately what I have given in the previous problem. So this will gives you the state model for state variable, and this will gives you the expression for what output variable ila. Now finally the last model here in this representation is he will be giving you, state model. He will giving you the state model వైస్ ఆపోజిట్ హీ విల్ ఇంతవరకు మనం ఇది క్యాలిక్యులేట్ చేసినాం, నౌ ఇన్ సమ్ కేసెస్ హీ విల్ బి గివింగ్ యూ ద స్టేట్ మోడల్ అండ్ హీ విల్ ఆస్క్ యూ టు ఫైండ్ అవుట్ ద ట్రాన్స్ఫర్ ఫంక్షన్. What is transfer function? Ratio of what? Output and y by input u in terms of Laplace transformation. So in this case, how to convert the state model? State model and x dot is equal to ax plus bu. How to convert the state model x dot is equal to ax plus bu into the transfer function? How to convert that one? We will be discussing in the next class. Next class lo I will try to go for clearly. I will explain you about this last concept in the case of representation, and I will conclude the same thing. So how to convert the given state model into transfer function, ఒక స్మాల్ ఎక్స్ప్రెషన్ ఉంది, దాని తర్వాత దానిపైన ఒక 2 or 3 couple of problems we will solve. With that this concept will be completed. Then after that directly in the next class I will go for second topic. Okay, so here is the end of my class. As here is the end of my class. So if you're having any doubts, be feel free here to ask. If you're having any doubts, be feel free here to ask. I just here is the end of my class. If you're having any doubts, be feel free here to ask.